Alright guys, so we're going to talk about how to identify conic sections in standard form. And listen to me carefully. If you will pay attention, this will help you determine with ease what they are. And this is going to be a really short lesson. I'm not going to give you a lot of examples because honestly it'd be like doing the same thing over and over and over again. So you should have enough information to do everything. Alright, so we've talked about three types of conic sections. We've got circles, ellipses, hyperbolas, and there's actually a fourth, parabolas. We've talked about parabolas before, just not in terms of being a conic section. And we're not going to talk about the specifics of parabolas, but you do need to know how to identify what they are. So if you will pay attention, this will make this so easy for you. So when you look at the equation of a conic section, these should look familiar to you because you've just done them, only you went into detail with them. This time you're just identifying, is it a circle, is it an ellipse, is it a hyperbola, is it a parabola, okay? So circles. Circles always have two squared terms. X is squared and the y is also squared. Circles also always have a plus sign between those two things. Now, I won't say always, but most of the time that circles don't have a denominator under the x squared and the y squared. But if they did and they were the same, that would make it a circle. Okay, they're also equal to the radius squared. The thing about ellipses is that they're a little bit different. Alright, so they're very similar. And they're the same. They're really similar to circles in that they still have an x squared and a y squared. They have a plus sign in between the x squared and y squared. But their denominators are different. If they were the same, it would make a circle. It wouldn't make the egg shape. Alright, and they're always equal to 1. Hyperbolas are really similar to ellipses. The only difference is that they have a minus sign. They still have they can have same denominators. That's why I didn't put different denominators. They can have the same. It doesn't matter. So really the main difference between these two is that the ellipses have a plus and the hyperbolas have a minus. I don't really have an easy way to remember that. You just kind of have to. If you want to think of it as hyperbolas are two butts facing each other and that's negative, I don't know. Come up with something, okay? Anything that helps you remember. Last are parabolas, and this is the easy one to identify because all of the others have two squared variables, whereas parabolas either just the x is squared or just the y is squared. They will not both be squared. So let's get a little practice here. So I have a list of things to think about. First thing, I always like to look at the sign. I have a minus sign in between two variables that are both squared. So the x is in a binomial that's being squared, and the y is being squared. So it's not a parabola because both things are being squared. So then I have to look here. Well, circles and ellipses both have plus signs. So since this has a minus sign, that makes this a hyperbola. And if I want some justification here, I can say it has a minus sign. If you want to just put minus and then a sign, that's fine. And two squared variables. So in other words, you're just telling me why you chose hyperbola. What justification? Alright, so if you look at number 2 here, I notice that y is not squared, but x is squared. And since we only have one thing being squared, that makes this a parabola. And my justification is that only x is squared. Number 3, I see that x is squared and I see that y is squared. So that means it's not a parabola. I notice that I have a plus sign in between. So that's going to narrow it down to either a circle or an ellipse. The only difference between those is the denominators. Alright, so since I have two different denominators, an 8 squared and a 10 squared, by the way, this will probably just say 64 and this will say 100. Either way, it shows you they're different. Since they have different denominators, that's going to make it an ellipse. And my justification is that it has a plus sign. Different denominators, just going to abbreviate here. Different denominators, and also that I have two squared variables. That is why I decided that it was an ellipse. Alright, number 4. I notice that x is squared and y is squared. That means that it is not a parabola. I look in between. There is a plus sign, so that means it's either a circle or an ellipse. So therefore, the only difference between those two is the denominators. And if you look, this would have a denominator of 1, and this would have a denominator of 1. That's the same, or you can just say they don't have a denominator, alright, which is fine. It's also not equal to 1. So, therefore, that makes this a circle. And my justification would be, you can either say no denominator or same denominator. There's a plus sign. And I have two squared variables. Alright, let's do a couple more. So I look at this, I notice that x is being squared and y is being squared. That means it's not a parabola. Then I look between there and I notice that I have a minus sign. So the only thing that has an x squared and a y squared and a minus sign is a hyperbola. And I chose that because there's a minus sign and two squared variables. Alright, the last one. So I look at this. I notice x is squared and y is squared, which means it's not a parabola. I look and they have a plus sign between, so that knocks out the hyperbola because this would be a minus. And then I also notice that they have the same denominator, or no denominator, so that makes it a circle. Chose that because it has the same denominator and two squared variables. And a plus sign. Make sure when you do your work that you show your justification or why you chose that.